So now we are going to modify the cos to a. So cos to a will be cos to a. Say it, cos to a is equal to cos squared a minus sine squared over a. So we know that cos squared of a plus sine squared of a is equal to 1. So implying that our cos squared of a is equal to 1 minus sine squared of a. So substituting, we shall have cos to a is equal to 1 minus sine squared of a minus sine squared of a. So implying that our cos of 2a would be 1 minus 2 sine squared of a. So it can be in this form. We can now make, so all our sine squared of a will be 1 minus cos squared of a. So substituting, our cos to a will be cos squared a minus 1 minus cos squared of a. So which will give us cos squared of a minus 1 plus cos squared of a. So this will give us 2 cos squared of a minus 1. So our cos to a will be equal to that. So this is another form which cos to a can be expressed. So we are having that. So prove that 1 minus cos 2 theta over sine 2 theta is equal to tan theta. So if you have such a case, so when you observe, we have a double angle here and a double angle here. So we want to obtain tan theta. That means our numerator must have sine, then down must have cos. So we are going to eliminate that cos from the numerator. We change it to sine. So but remember, cos 2 theta is the same as 1 minus, it's the same as cos squared theta minus sine squared theta. All of, now this one is the same as 2 sine theta cos of theta. So here we shall have what? 1 minus bracket. So cos squared theta is the same as 1 minus sine squared theta, again minus the sine squared theta. So from the other identity, cos squared theta plus sine squared theta is equal to 1. So when you make cos the subject, cos square the subject, so you have 1 minus, which is this, substitute here. So all of 2 sine theta cos of theta. So this will be equal to, now 1 minus, so this one will be minus 2 sine square theta, so it will be 1 minus 1, then plus 2 sine squared theta of 2 sine theta cos of theta. So this one and this will go, so we shall remain with 2 sine squared theta over 2 sine theta cos of theta. So 1 sine would go with this, so we shall remain, and the 2 will go with the 2, so we shall remain with sine theta over cos theta, which will give us tan of theta as squared. So our last example is prove that cot 2x plus cosec 2x is equal to cot 2x. So I told you when you find such case, you have to express it in the forms of sine and cos. So looking at this, cot 2x is the same as 1 over. So it is the same as 1 over tan of 2x plus cosec is the same as 1 over sine over 2x. So now, but tan is the same as sine over cos, so which will now become cos 2x over sine 2x plus 1 over sine 2x. So when we take the LCM, we shall have sine 2x. So we shall have cos of 2x plus 1. So this will give us, now cos 2x is the same as what? So from our identity, the identity we saw, the same as cos squared x minus sine squared x plus 1 of, so sine 2x is the same as what? 2 sine x cos of x. So this will give us what? Now since we have one to cot, and we know that cot is cos over sine, so our denominator must remain with cos. So I'm going to eliminate sine, so I will have cos squared x minus, what is your sine? It is the same as 1 minus cos squared x plus 1 all over 2 sine x cos x. So this will give us cos squared x minus 1 plus cos squared x then plus 1 all over 2 sine x cos x. So this one and this, they will go, so we shall be left with 2 cos squared x over 2 sine x cos x. So 1 cos here and here, the 2 and the 2, so we shall remain with cos x over sine x, which will give us cot x. Yes, thank you for watching. Feel free to subscribe our next, and turn on the notification bell to watch our next videos. Thank you.